Okay, so in this video, let's understand what the different types of machine learning problems that you can come across are, and in general, what is a machine learning algorithm. Okay, so let's say you have a data set of uh, n features x1, x2, all the way to xn, and you have this is n data points, and you have m features f1, f2, all the way to fm. So these are your data points and these are your features. So how does this look like in a data set? A data set is basically nothing but, it's a column. It's a data set, right? I mean, it's nothing but a table. So what are your data points? Your data points are your rows. Your different rows are your data points, and your columns are your features. So, I can have F1 over here, F2 over here, all the way to Fm over here. F1, F2, all the way to Fm. And every row is a data point, okay? A data point is an observation from real life. The feature or the column is a characteristic of that observation. So I can have x1, x2, all the way to xn, right? Features are the characteristics of the data point, and the data point is what you observe in real life. So there's a very popular data set in the world of data science. It's usually considered as the hello world of data science. It's called the iris data set, which the data set consists of four different flowers, and it consists of three different flowers, and each flower has four features: the sepal length, sepal width, the petal length, and the petal width. Okay. And the idea of any machine learning algorithm on a very high level, right? The idea of a machine learning algorithm is to find a function f such that if I input my data set, this is x, this is just x, it gives me some output, okay? And this output is usually the output that helps you identify what class your data point belongs to, right? So when it comes to the different types of problems you may face in machine learning, there are two different problems that you can come across. The first one is classification. Okay, classification tries to segment your data points into different classes. Okay, so the classes can be something like, let's say, whether depending on the if the data point is about humans and the features are something like hair length or eye color or something like that. Classification, if it's a classification task, you might want to understand whether the human is a male or a female, right? That is one classification task. That's a very simple classification task. So how can you do that? You can have different features. Usually, it's usually seen that men are taller than women in general, and women have longer hair than men. So that really helps identify whether that can help identify which class your data point belongs to. So the entire point of a machine learning algorithm is to find this function f, such that if I give it a point x1 and it passes through the function f of x1, it gives me then output, and it tells me whether my data point belongs to male or female. Okay, that is what a classification task is. So what is a regression task? So in case you don't have to segment your data point into one of the classes, what if you want to find a real value for your data point? If I have to give a data point f of x1, and if I get a real value outside, okay, this can be a real value in any range. It can be between minus 1000 to 1000, anything. It can be anything. So that is what regression helps me do. It helps me it basically gives me, for every data point that I input, it gives an output as a real value. So that's the difference between classification and regression. And so how do we go about doing this? Well, what you do is you take a training data set. Okay. So what machine learning algorithms do is that they learn from your data set. Okay. The In the beginning, the you have a very basic idea of the function that you want to apply, but it's not optimized. So you want to optimize it. You want to find the best parameters. As we'll see later, that machine learning algorithms have something called hyperparameter tuning, where you're trying to find the best parameter that gives the highest probability for highest, it gives the best performance metric for your data point. So that's what the training stage does. Okay, there's a training stage where you input a training data set, and the machine learning algorithm, through a process of trial and error, tries to find what parameters best resemble the structure of this data set, of this training data set, such that whatever performance metric you're using on your data set, you get the best value as the output. Okay, that is what the training stage is. In the testing stage, what you do is you take another data set. Okay, it can be a part of this data set that you remove, but you have to make sure that this is data set that the algorithm hasn't seen before. Okay, because you want to see how well the algorithm performs on data that it has not observed for its optimization, right? So you take an entirely unseen data, which is the testing data, and you try to find the out and you see the output, and you compare how the output that the machine learning algorithm has given you, how is it to the actual values that you have for this data set using the function f of x. And that helps you identify whether your model is correct or wrong, or whether it needs more further fine tuning, whether it needs more training and everything else. So that's in general how how machine learning algorithms work.